Good evening, ladies and gentlemen. Thank you for giving me a screen. My name is Gawel Solosky from Bengal University. I will talk today about biofuels produced bioethanol and biobutanol produced for biomicrobial consortia. What we need to remember that biofuels need to replace our oil, kerosene from conventional methods. The main trouble of biofuels is that ethanol has bioethanol usually has higher corrosivity, higher viscosity than normal diesel oil and cannot be used in some truck or truck engines. But now the solution is using biobutanol with addition of fatty ethylomethyl esters. How they are produced? They are produced by algae. I will be basing this my talk today on work of Professor Selen Montserrat Garcia Solares from Mexico Technical University and her chapter Circular Economy Involving Microbial Consortia in Consolidated Bioprocesses to Produce Biofuels. There is several forms. The Professor Garcia Solares divide into 4 generations. First is produced directly for wheat from plants like cane corn wheat. For example, in hydrogen would be sugar or simple sugar glucose. Second generation, biofuel from lignocellulose biomass, so produced from waste. And third generation is from microalgae, which is composed because it can be from hydrogen use and some for liquid. And fourth generation is using these processes in genetically modified to produce high efficiency to be industrial acceptable for using. The question is only safety, but that is not involved. The fourth generation is using, in case of first generation, is production from cane to ethanol, which is using simple saccharification and malts, yeast for production of ethanol, but it needs some distillation. In case of second generation, we have the above pretreatment and biomass is through anaerobic digestion to produce methane or hydrogen or fermentation to produce ethanol. The third is similarly by algae cultivation, which can be to biomass and some feed, as Professor Liberatos mentioned, to the dark fermentation, and which is not digested. It can be trans-esterification because it contain a lot of lipids that will be non-digested but so highly by anaerobic bacteria and to produce biodiesel. The fourth is this modification genetically of both cases. The food waste are very big trouble. According to Sir Garcia Suarez, 1.3 billion tons of food worldwide is wasted. It is huge waste for our landfills. Therefore, we need to utilize, and one is stack fermentation for hydrogen and other for biodiesel very well. The biorefinery is producing not only, but also biopolymers, which can replace the conventional source of polymers. The advantage is low cost, low energy, but quite high time if not modified bacteria. So the case is much higher time, but much lower energy than pyrolysis. In biofuels are very important because can recycle the waste into the biogas and biofuels to fulfill our energetic and chemical demands. And can be also made to solid biofuels, so bottom, to make chars, which are excellent for production of tars and fertilizer. But pyrolysis contain much higher energy. This is trouble. As Professor, so the algas are organisms that produce hydrogen by biophotolysis. But it's not so high as dark fermentation or another fermentation because it needs sun, which another variable. This can be combined with microbial electrochemical process, which are very useful to split ammonia, so can be waste. So we need to fulfill our demands to combine. The problem of algas is some algas are very unsafe for river fresh water and can lead to death as our other river. Therefore, Professor Dembowski recommended to collect and way to utilize using this anaerobic digestion. This can produce glycerol usually. That can be also transmitted to glucose but lower rate by that acetate or glycerol. There are also cyanobacteria, which are also photosynthesis bacteria, not so smaller, because green algae advantage are big and are more easily controllable. The renewable biofuels needs also, as usually, distillation, which needs some energy. So the solar and photovoltaics needs to be included. These photovoltaics needs can be produced by polymers made from biochars and from these biopolymers and pyrolysis mostly. Another produce phenolic compounds can be produced as levulinic acid, which can be important factor to pharmacy. Formic acid also produced from lignocellulose. And also for glucose, levulinic acid can be produced by hydroxymethyl and hemicellulose also can produce. So this hemicellulose, in case of lignocellulose material, is to gain highest efficiency of fermentation function and conversion in case of agar or cellulose and hemicellulose and remove lignin. And lignin will be source of some biopolymers there. And this can find to avoid trouble to use the bacteria and algae which are native to avoid some natural disaster. So we are need to seek because in every place are some bacteria and algae suitable for uh, suitable for biofuels in the region. So this is biofuels by bacteria and algae are very promising, and I hope that development will help us to live more cleaner and more renewable way that help us to prolong our prolong our existence in the earth. Thank you very much for listening to me.